will be coming up too. All right, we are now recording. Let's go to the current slide, and we'll get there hopefully in a couple of minutes, if it ever gets to the current slide. This computer is being very slow and very strange this morning. Well, it's back to where it was. Still not, there we go. All right, that's where we're going to pick up when we do get started. Now here's the regular announcements. 1 week from today will be on February 12th, 9:30 to 11:30 on the Birmingham West Campus, the academic building, that's the B Hall. All up and down that hall, there's going to be tables set up for various universities and colleges, and they're in our college transfer fair days, okay? Hopefully it'll be a fair day, okay? Then on Thursday, 1 week from tomorrow, February 13th, on this campus, 9:30 to 11:30, in this building, Building A, but over somewhere near the cafeteria. They say it's in the cafeteria, but I can't imagine they can set up this many tables in the cafeteria and still have room for anyone to eat breakfast or lunch. Okay, so I have a feeling it's going to be in the faculty staff dining room. That may even be crowded, so they may spill out into the hallway outside of there or into the cafeteria somewhere, but they'll figure it out. And that will be 1 week from tomorrow on this campus. Now, also, I think I've announced several times this fantastic opportunity, and there's more of them out there. This is the only one that I've printed off so far. Research experience for undergraduates, University of Illinois, University of Arkansas, and Howard University. 10-week internship exposes you to academic research in fields of mechanical, electrical, and material engineering. Fantastic learning experience. And how much does it cost you? Basically not a dime. They pay you $5,000 to participate. Fantastic. And you receive free housing, and I think that includes a meal plan, so free food, and they fly you there and back one time, okay, one round trip ticket, okay, and you gain enormous learning opportunities. The deadline for this on this page says February 15th, which is a little suspect because that's a Saturday, but in the brochure they say February 17th, a Monday, which makes more sense. All right, that's that stuff. Now let's get to this stuff. Two fairly important things I want to mention. The first, when I entered attendance on Monday, everybody was hunky-dory. When I entered attendance for yesterday's classes, I noticed some people were missing from the list that had been attended. Okay? If someone comes for inclement weather, it looked like. All right, this is Houston? Yeah. All right. Make sure I recognize you under all that stuff. Okay. There were some people not on the roll anymore who had been attending. Now, the only thing I could surmise from that is they may have removed unpaid students from the rolls. Okay? Then today, actually, we were supposed to have been done earlier, but I got the email today that we had to do our no-show report, which is all the students who have paid for the class but never attended. Of course, all of you had attended, but again, there were 2 people not listed on the roll that had been on the roll Monday. Okay, so if you haven't completed payment, or not absolutely certain that you've completed payment, check at the financial. The cashier's window and see if everything's hunky-dory. Now, my guess is you probably aren't able to access Student Suite if you haven't paid. I don't know if that's the case or not. I don't know how students can tell. What I don't know is why they don't notify students to send out a thing. If you haven't paid by this and so date, you're going to be removed from classes. But they usually don't do that. They usually send something to instructors and have some sort of long rigmarole. I may have missed it, and if I did, I'm sorry if I did, but please get your payment caught up. Now already they've done this. I also noticed this yesterday with not very pleasant response. What they had done, they had removed one of my students from one of my classes and then put them back in. Now, of course, I've been entering attendance every day, but when they put him back in, none of his attendance was there. So I had to go back in every day of the term so far and put his attendance back in. So that might be what's going to happen. So anyway, check and make sure that the bills are paid and that everything's all right. There's some weird things that they do sometimes. All your tuition may be paid by something, but it may not pay your insurance, which is $10, $11, something like that. If that's not paid, they remove you from the roll. So make sure, or come and see me after class. I'll let you know whether you're one of the two students who wasn't. One of them's not here, so that student may not be coming back to the class. I don't know. Any questions? Anything we've done so far? All right. Where we were last time, we're at Chapter 2, Limits and Their Properties. 2.5, the last section in Chapter 2, Infinite Limits. And I'm sorry Kyle has left, but when he comes back, remind me to make that other announcement. I was going to say it right now, but I want to wait till he gets back. But anyway, we're on Example 5 on page 111. And here it is. Now, okay, sure. That brochure, yeah, those two emails, that's it. They've basically done everything for you, so I don't know why they do that. I wish they did just that. But here, there's a rather strange way to say this. Oh, here's what it is. Here's what the problem is, okay? And they started giving you the answers, okay, before they even gave you the problem. So here was the problem. What's the limit as x approaches 0 of 1 plus 1 over x squared? Okay? Well, as I said, they gave you the answer before they gave you the problem. The limit of 1 as x approaches 0, of course, is 1. That's pretty obvious. But the limit of 1 over x squared as x approaches 0, this expression is totally undefined. So therefore that limit doesn't exist. Okay? Now, they can say this, and it's okay, it's infinity. And the reason they can say this is that x squared is always positive, but as x is approaching 0, that's getting to be a very small number. 1 divided by a very small number is an infinitely large number. Okay? So that's why they can say this. Now, if they didn't have the squared in there, the limit still doesn't exist. Okay? But you couldn't say infinity, because then it could be plus or minus infinity. So then you'd have to either put in plus or minus infinity. What drives me crazy, why don't you just say does not exist? Okay? It's infinity. Yeah, it doesn't exist. It's going to positive infinity, but that's only because this is a square they can say that. If that was not a square or a cube or a fifth or something like that, then you would either have to say plus or minus infinity, or you just say it doesn't exist. Well, why don't you just say it doesn't exist? But that's my little soapbox. I'll get off of it now. Okay? Here's the second one, which they are not showing you anything about. Let's just try to reason it this way. What would this one be? The limit as x approaches 1 from the minus side, from the left-hand side, of x squared plus 1 over cotangent pi x. I'm sorry, I should have covered that too. What does that give us? Well, the numerator is what? Okay, and that would be 1 plus 1, which is 2. Okay, high level math today. Okay, so the numerator would be 2. What would the denominator be? Cotangent of pi coming from the left-hand side. Say again? Okay, cotangent is which? Tell me the trig identity for cotangent. It's what? All right, need to talk with the trig teachers. Okay. Cotangent is what? Okay, tangent is what? In terms of other trig functions, sines and cosines. What is tangent? Oh, come on. Okay. Tangent is sine over cosine, and cotangent would be cosine over sine. Where is sine? Where is your problem here, folks? When sine would be, okay, this is, everything's upside down now. So if this is cosine over sine, that would put sine up top and cosine in the bottom. Cosine is, try to hold them with hands there, okay, cosine of pi is, in responses to that, cosine of pi, I really need to talk to you trig instruction, okay, is -1, okay, all right, but how about that sine that moved up top? Sine at pi, 0, okay, so if sine is 0, you got 1 or 2 times 0 over -1. Hey, that's going to be 0. Okay. Now, sure, this is going to negative infinity as x approaches this from the left-hand side, but that's because the sign is in the denominator. But when you put it over that, it flips it to the numerator, so that's going to be 0. Now what they're saying is, because this is getting infinitely large, this is 2. 2 over an infinitely large number is getting closer and closer to 0. Okay? So that is correct, but you wouldn't even need the minus sign here or the minus sign there, because who cares? If you flip this over, you see that's going to 0. Without a plus or minus in front of it, it doesn't matter. So that's going to 0. Okay? Oh, I forgot this. All right, what's this one doing? The limit of 3 times sine log x, as x is going to 0 from the positive side. What is that going to? What's happening to the log as x is approaching 0 from the right? Where is log 1? Infinitely negative, okay? So, this is going infinitely negative. 3 times infinitely negative, still infinitely negative. So they write that. Why don't you just say it doesn't exist? Because x cannot equal, you cannot put a 0 in for log. Yes. From the right side. It can't even go to the left side, okay? But from the right side, it's going to finish. Now, I don't know if you remember, this isn't going to be projected, and perhaps I should do this with you. One time I had to talk with you. Now it seems to slip your way into little. Okay. You're trying to get rid of me, huh? Okay, I saw that. Okay. Noted. Okay. Now, I'll start this strangely. We're looking at that last one there, log x. I'm going to start with doing alpha of x is equal to e to the x. Why would you do that? Tell me basically how that would apply. No, not e to the x. What's e e to the 0? Say again? 1, of course, okay? So when x equals 0, e is 1. Okay? Now, if you go to negative numbers here, that would be, say, negative 1, e to the negative 1 would be 1 over e. E is about 2.7 or so. So it's about 1/3. Somewhere around that. It would be there. And then 1/9 or somewhere around there. And then 1. So see on this side, it's approaching 0. Never gets to 0, but is approaching 0. Okay? Now let's go to the right. X is 1. What would that be? E to the 1, which would be e. E. Okay, no. And that would be about 2.7, right? So this would be 2.7, somewhere right about there. Okay? 2 would be close to 9, but not quite 9. So that would be 3, 4, 5, 6, 7, 8, 9, somewhere around there. And then the next one would be near 27. Maybe around 25. So it's going infinitely high there. That is your exponential function. Okay, well, wait, we're doing log function. Why did he do exponential function? It's sort of nuts. Well, he is sort of nuts. Yeah. Why would I do an exponential to show you log? Are they related? Second cousin, third, twice removed. They're the inverses of each other. Okay? So what you do is flip the x's and the y's. Okay, so this would be 1, 0. This would be 0, 1. This would be 1, 2.7. This is 2.7, 1. Okay? So this is going like this, and this is going like this. This is approaching 0 here, approaching 0 there. Never can be 0, never can be negative. This is your log function. G of x equals 1. So that's why as x is approaching 0 from the right-hand side, this is going infinitely negative. Okay? And that's why they put negative infinity. Why don't we just say it doesn't exist? Okay? It does not exist. Here it would if you're going this way. But, so that's why, and sorry people at home, you couldn't see me draw that, but it was, you should be here, shouldn't you? All right. Now, nice, fancy. Grace, I didn't even know it was up there. Probably put it there. All right. Do I need to leave this in longer? Otherwise, I'll forget to erase the period. So, now, yeah. What I was going, my second announcement I was going to make, besides the be sure you're paid everything, was do not leave class without a gift from me, okay? The first test, okay. So I knew you sometimes had to leave early and some of the others, so don't leave class without it, okay? All right, so there's the C part. Make sense now? Okay. Let's do the D part. Okay, again, let me cover all this. All right. What's the limit as x approaches 0 from the left-hand side, okay, of x squared plus 1 over x? Any idea what that would become? Well, x squared doesn't contribute anything. It's approaching 0, right? Okay, so that's going to 0. How about 1 over x? It does not exist. So that would be, and since it's coming in from the left, that would be approaching negative infinity. Okay? To me, far better say it doesn't exist. Okay? But they like to use these symbologies. All right, that was example 5. Any questions on 5? And that, by the way, does end section 2.5. Homework exercises here, I think I probably gave them to you before, but in case you missed them, either 3 or 5, they're both at Calc Chat. 3's at Calc View. 7 or 9, both at Calc Chat. 7's at Calc View. Any of the odds 11 through 15, all at Calc Chat. 17 through 31, all at Calc Chat. 21's at Calc View. 33 or 35, both at Calc Chat. 33's at Calc View. 37 to 51, all at Calc Chat. 41's at Calc View. 53's at Calc Chat. 55's at both Calc Chat and Calc View. And you can explore doing 57 or 59. One's writing something and the other is sketching something. They should both be at Calc Chat. If they are, do them and check them out. If not, yeah, I wouldn't mess with them, but it's up to you. 61 should be at Calc Chat. 63 should be at Calc Chat. And then 65 should be at Calc Chat. Do any of those that you want to. 67 and 69 are both true-false. They should be at Calc Chat. 71's finding a function that's been lost for a while. Okay, never mind. And 73 is a proof if you're into proofs. They both should be at Calc Chat. 75 and 77 should both be at Calc Chat. You could do either of those or both if you chose. All right. They have a little section project if you want to do section projects. Okay. Now, if you haven't had it, yes.
I had a question about this.
Okay, sure. Sorry.
If it wasn't cotangent, it was maybe tangent.
If this had been a tangent here, tangent of pi.
Yeah, tangent pi or like secant pi, something like that.
Okay. All right. Now, there's several things going on with that. Okay. If it was tangent pi x, okay, numerator is still 2, right? Tangent of pi x, okay, because tangent of pi is defined and it's 0. So that would have been undefined. That's how I would say it. Now, as it's approaching 1 from the left-hand side, the tangent of pi being 0, as x is approaching 1 from the left-hand side, tangent would be 0. And from the left-hand side, it's approaching negative infinity. So, I mean, it would be a very negative number. So that would be a minus infinity, the way they're writing. I would say it does not exist. Okay, not defined. You know, whatever you want to say. The limit does not exist. Does that? Oh, wait. That's not right. Tangent of pi is. Oh, that's right. No. Yeah, the tangent of pi is 0. Right. Yeah, we just said that before. Now, if that was tangent of pi halves, okay, pi halves x, okay, x pi halves, however you want to say that, then tangent would be approaching that would be approaching 0 from the negative side. No, it would be infinite, infinitely negative, and then that would be the same answer as 0 here, because tangent of pi halves x, as x is approaching 1 from the negative side, would still be a 0. Okay. So that's because you have an infinite number in the denominator that drives the whole thing to 0. So I don't know. Is that what you were asking? Yeah. All right. So if you don't feel like you've had enough homework exercises to practice on, these are all at Calc Chat, none of them at Calc View, but you could do number 1, 3, 5, 7, or 9, or both if you chose. Any of the odds 11 through 27, these are review exercises starting on page 115. 11 through 27, all those would be at Calc Chat. 29 or 31, 33 or 35, 37, any of the odds 39 to 49, 51. Sorry. Oh, okay. Whoops. You don't want the key, I know that. Okay. All right. All right. Oh, yeah. He's on his way to D.C. That was Devontae. Mark him here because he did come by. Okay. I don't know where I left off. Through 49. 51 should be at Calc Chat. Any of the odds 53 to 57 should be at Calc Chat. 59 should be at Calc Chat. Any of the odds 61 through 67 should be at Calc Chat. 69 at Calc Chat. 71 at Calc Chat. 73 at Calc Chat. Any of the odds 75 through 81 at Calc Chat. 83 through 93 at Calc Chat. And 95 should be at Calc Chat. Okay, now, I can't say for sure, but I know some of the text, I haven't checked this one out, but I really can't. Well, yeah, maybe I can. I don't have the instructor edition. So let me see if in the back of the book, the review exercises may actually have all the answers, but may not. Let me see. It says answers to odd number exercises. So I'm guessing these are not. I don't know. Has anyone checked these out yet? Okay. 2 point. Review exercises, chapter 2. They're still just odd numbers. Some texts have all of them for review exercises, but this just has odd numbers. And then there's a problem-solving section if you want to look at that. Again, the odd number exercises they have in here are at Calc Chat. So if you want to play around with number 1, 3, any of them, 1 through 13, you can. That's up to you. All right, any questions? Now, let's say, since we have finished Chapter 2, let me go on and give you the Chapter 2 test. I don't want Devontae to have that big of a jump on you, so let me get it to you as well. Obviously, I don't think you can do all the work on this page. If you can, that's all right. You can write on the back if you wish. But the odds are, I would guess, you probably are not going to need scratch paper. And if you do, I suggest, I don't require, you turn in your scratch work. Because I give as much partial credit as I can get away with. And if I can see your work and see you're going in the right direction, even though you may not have wound up with the right answer, I can give you more partial credit than I just see a wrong answer. I don't know how you did. So I suggest you turn in the thing. Now, this is done in Word, and for some reason, it lifted everything. I didn't type it. This is straight out of the test bank. As you see, it's Cengage Learning powered by Canero, whatever that is. They did it, and they always superscript the things that I think are in equation mode. I was real tempted, but I resisted temptation to type it over in WordPerfect, which does it much nicer than this. But I thought, no, I don't want to do that. So I just edited what I could, but I couldn't correct that. So anyway, it's a bit bizarre. And I know there must be some reason they asked for number 4. There's got to be a calculus connection there, but you don't need it. Okay, so just do number 4. Okay, that section had precious few. All right, too late. Okay, you had precious few good questions anyway, so I left it in there. Okay. So anyway, now when is this due? I always give you at least a week to work on it, okay? That gives you, there's 2 reasons for that week. 1, you always have 1 more day you can come back and ask questions about it, okay? Like, I don't understand what you're asking here or they're asking here because these are all their questions. I'll try to help you figure that out. or I can't read this, or is this really right? I'll check into it and see if they've not made a typo. But this is all their stuff. I didn't type this, so this is all theirs. Hopefully it is right. I haven't checked it all, but hopefully it's right. That also, the other reason I give you a week is you always have a weekend to work on it. And some of you may be working or have other things during the week, and your weekend's your best time to get things caught up. So you always have that. Now, here is a question I will answer if you ask it. Can you do number 3? And my answer will probably be, yes, I can. Okay. Yes. I'm sorry?
Can you do number 3?
Yes, I can. Okay. But I'm not going to do number 3. Okay. That's the second part of the question you may not like. Okay. But here's what I would say about number 3. Find one like it in the book. I'll do anything in the book as long as it's not this exact question, which I doubt if it is. So any of your homework exercises, any of the examples, anything that would lend that's why I told you about review exercises, anything you can find in the book. If you can't do one here and can find something in the book that's similar to it, I'll be glad to do those. I will not do the test question. That's what you're getting tested on. So my answer will be, yes, I can. I hope I can anyway, but I'm not going to. Okay. So let's move on to, oh, yeah, there it is. I wondered what happened to the slide set. Okay. And again, PowerPoint is incredibly slow today. There it's coming back. So let's can that one. Huh. Wow, it is slow. I don't know what its problem. There, finally. Nope. Yeah. Well, nope. Let me do it this way. Ah, there we go. Maybe this time it'll work. Maybe. All right. So we go back to this, and we're getting into Chapter 3. Chapter 3 is the basic chapter of the course. 8 sections, it's a lot there. We may not do them all. In fact, I don't think we'll have time to do them all, but let's do what we can. Now, the first of these continue with the limit idea, which is sort of drags, but after a while, then we'll get into the real calculus in my mind. Okay. But it seems to be having a hard time opening things. So here, finally, PowerPoint is awakened. And it's starting, but not doing very much. Now it's loading and not doing it very quickly. Now it's processing and not doing that that's doing more quickly now. It's taking its sweet time. Now it's processing again. Ha! We're there. So let's go from current slide. All right. Differentiation. Y'all familiar with it? No, some? Yes, okay. So what we mean by differentiation is, another word is the derivative. Familiar with that term? May not be, okay? And the tangent line problem. I never knew the tangent line had a problem, did you? But it does, okay? And that's where we're going to start from here in differentiation. So our objectives here are to find the slope of the tangent line to a curve at a point. And I'm almost guarantee you they're going to do it in a very long, drawn-out way, okay? Then we'll use a limit definition to find the derivative of the function, and that also is going to be somewhat tedious. And then finally, we may be able to understand the relationship between differentiability and continuity, which is a pretty important concept itself, okay? So let's start with the tangent line problem, okay? Calculus grew out of 4 major problems that European mathematicians were working on during the 17th century, the 1600s. One of these was the tangent line problem. The second was velocity and acceleration problem. Third, maximum and minimum problems. And the fourth was an area problem. Okay? Now, derivatives work for this one, these, and those. The area problem is integration. We'll get to that toward the end of this course, okay? And really get into it in Cal 2. Each problem involves the notion of a limit, and calculus can be introduced with any of the 4 problems, okay? But we're going to focus on these 3, starting with the tangent problem. What does it mean to say that a line is tangent to a curve at a point? Essentially, the problem of finding a tangent line at a point P boils down to the problem of finding the slope of the tangent line at point P. Does that not almost sound redundant to you? It's blah, 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 and doesn't say anything else. You can approximate this slope by using the secant line. Now, we've already been doing this, right? In chapter 1, okay, or chapter 2. Okay, approximate the slope by using a secant line through the point of tangency and a second point on the curve. Okay? So, for instance, if you really are interested in what the slope of the tangent line here at C f of C, that would be a line that's tangent there, you don't have a second point to measure your slope from. So you pick a second point here, okay? That's not going to be the same as the slope of the tangent line, but it's fairly close. So what you do then is let this point come closer and closer and closer, and now this secant line is getting closer and closer and closer to what the tangent line is. And then the limit, oh, there's the limit. You know what the slope of the tangent line is. The slope of the tangent line limit as your delta x is smaller and smaller and smaller as it's approaching 0. That's where the limit comes in. So we'll start with the secant line through alpha C, C alpha C, that's xy, okay? And this point up here, which is C plus delta x, is the x coordinate of it, and alpha C plus delta x is the y coordinate, okay? Now the difference between these two is alpha C plus delta x minus alpha C. That's your delta y. Your delta x is the difference between C plus delta x and C, which is just delta x. So what is the slope? Change of y over change of x, right? Remember that? Way back, you knew what the slope of a line is. You have 2 points on the line, y2 minus y1, or x2 minus x1. That's your slope of the line, okay? So here's your y2 minus y1, there's your x2 minus x1. That's your slope of the secant line, the quotient of those two. If C f of C is a point of tangency, not secant C, okay, and C plus delta x, alpha C plus delta x is the second point on the graph of x, then the slope of the secant line between the 2 points is given by substitution into the slope formula here, okay, which is just what we said, alpha C plus delta x minus alpha C, that's your change of y, over this, which is just delta x, that's the slope of the secant line. I think we sort of already done this. The right-hand side of that equation is the difference quotient. You remember that from pre-calculus algebra? Please say yes, okay? All right, good, okay. And the denominator, delta x, is the change of x, and the numerator is the change of y, okay? We've already, they said it here, they're saying it here, blah, 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 okay. You can obtain more and more accurate approximations to the slope of the tangent line by choosing points closer and closer to the point of tangency. So this one, point of tangency is down here, this is the secant lines here. Get closer, you're closer to that curve. Ooh, that's awfully close. There's a tangent line. Getting closer and closer and closer. So your delta y over delta x, that's the tangent line, that's the secant line. And you're letting the delta x is smaller and smaller. Well, of course, as delta x gets smaller, your delta y is also getting smaller. And guess what 0 over 0 is? Indeterminate. So that's what we're doing. We're taking the limit as that happens. Now this one's a fairly flat. Well, no. They really don't look like they're using the same curve here, do they? They're not. This is your point of tangency. They snuck it by me here. They put this one on the left-hand side, which is fine. It still works. Now you're letting this get closer and closer here, and that's still a tangent line. Or bring it down this way. This is the one we were doing before. In both cases, your delta x is approaching 0. Okay? So the slope should be the same. If it's the same point here, 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 here. No, here, 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 here. Those are all the same points. It looks like they are. Then the slope should be the same. It doesn't matter which way you're coming in. Okay? So you can almost imagine you have a limit problem, and you do. Oh, and limits are no problem for it. Okay. Definition of the tangent line with slope m: if f is defined on an open interval containing c, and the limit as delta x approaches 0 of delta y over delta x, which is the limit as delta x approaches 0, f of c plus delta x. Now the first one they had there, this was a negative delta x, so this was actually left of that one. It still is going to work, okay, over delta x. That's going to be the slope of the tangent line as you take the limit as x approaches, delta x approaches 0. If that exists, then the line passing through c f of c with the slope of that m is the tangent line of the function f at the point c f of c. The slope of the tangent line to the graph of f at the point f of c, c f of c, is also called the slope of the graph at x equals c. Okay? The slope of that curve at x equals c. That's the same as the slope of the tangent line to that point at x equals c. So here's an example. All right? And hopefully you're not going to have too much problem doing this. Find the slope of the graph of f of x equal 2x plus or minus 3 when c is equal to 2. Okay? Any of you want to guess what that slope may be? What kind of graph is that? What kind of function is that? A linear function. Do you know the slope of a linear function?
1 over 1.
Okay. A linear function has the general form of what? Mx plus b. Right? Does this have that form? Okay. And what does the m stand for? The slope. So you know the slope had better be. I don't think I have my pen set up yet. Let me get my pen. Come on, pen. This is really slow today. Okay. We think we're going to guess there's your slope. But let's do it the way they do it. Okay. I hate it when they do all the work for you. Wish that wasn't there. Okay. Let's just pretend that's not there. Okay. All right. So what is the slope of the graph? At that point, that would be the limit as delta x is approaching 0 of f of x plus delta x, or let's see, is that, did they say, no, they said c plus delta x. Okay. So let's do c plus delta x. I also don't like this problem because they have a 2 here, a 2 there. You're not sure which 2 is doing what. C plus delta x minus f of c over delta x. Everybody agree with that? So the first thing we've got to do is, and your c is equal to 2, so f of 2 plus delta x. I can't write. 2 plus delta x. Okay, I think I can read that a little bit better. Let's do what that is. What is that? 2 plus delta x. Alpha 2 plus delta x. Everywhere you see an x here, you plug in that instead. So what does that give you? 2 times 2 plus delta x, right? Okay, 2 plus delta x minus 3. Okay, let's work that out a little bit. That would be 2 times 2 is 4 plus 2 delta x minus 3. And 4 minus 3 is 1 plus 2 delta x. Okay, that's your alpha of 2 plus delta x. What's your alpha of c, which is your alpha of 2? C is equal to 2. What would that be? Not that hard. 2 times, plug in the 2 for x. Remember how to do this? Alpha of x is 2x minus 3. Alpha of 2 would be 2 times 2 minus 3. And what would that be? 4 minus 3, which is 1. All right, we got it done. Okay, so there's your alpha of 2. So what we've got here is the limit as delta x is approaching 0 of your alpha of 2 plus delta x would be 1 plus 2 delta x. That doesn't look much like a delta. Minus alpha of c, which is alpha 2, which is 1 over delta x. That looks a lot better, doesn't it? Okay. This would be the limit as delta x is approaching 0. And what do we notice in that numerator? One minus 1 is 0. So you have 2 delta x over delta x. And guess what that is? 2. The limit of 2. And what did we guess the slope was? 2. Okay, we got it. Okay. Now that, a little on the crazy side to even do that problem, but just to give you practice dealing with the limits and how you do the limits, how you do those difference quotients. Now, do you remember doing them in pre-calculus algebra and how much you loved doing them? Yes, I knew you remembered that. Okay. All right. Let me erase what I've done. Okay? No, y'all are still writing. Now, mine's kind of sloppy. Well, that's an understatement. Okay. But, hopefully you can follow. All right. Here is Joanne, right? All right. So all we're missing is Christian today. I'm guessing he may be sick. I've had him in several classes, and he hardly ever misses a class, and he's missed all week this week, so I don't know. All right. Now, I did make an announcement earlier, and let me make it again just in case you don't go back and listen to the thing. Sometime this week, they've done something weird to the system. On Monday, every one of you were showing up in the roll, okay? And by the way, the other thing I did, so I won't forget to do it, is passed out the first test. And do listen to the video for the class that you missed so far, because I talked about what to do on that. Okay? Earlier this week, on Monday, after class, I put the attendance in like I always do. It wasn't right after class, it was later in the day, but I did it. Okay? All of you were on the roll. Okay? Yesterday, after the end of all my classes, I put in the rolls for yesterday's classes. A bunch of students who had been there were not on the roll anymore. And here's what I'm guessing happened. I don't know this for a fact, that some of them had not completed payment and were removed from the roll. Okay? Now, actually one student must have completed payment, and then they put them back in the roll, and then I had to go in and put all his attendance from the first of the term. Okay. Then today, earlier, I've just found out about it today, they wanted no-shows, and when I went to do the no-shows, I noticed that a couple of you were not listed as on the permanent roll. So please check and make sure that you have completed all the payments. If you haven't, you may not be on the roll anymore. Therefore, if you try to access things like Blackboard or YouTube videos or your attendance or whatever you would access on Student Suite, you may find out you can't do it. That, to me, would be the day giveaway of whether you've been removed from the roll or not. I don't know if that works or not, but that would be my first guess. I don't see the student side of things, so please check that out and make sure you've gotten that complete. I can go and look at the official roll. I don't know how you tell unless that's what I say. Go to Student Suite and see if you can pull up things. If you have completed payment recently, then you're probably still okay. But if I just was saying, when I went to do the no-show report, which they had printed out at the end of January, I assume, because there was one student in one of my classes, not this class, but another class, who was he was on the roll, meaning he had paid, but they showed no attendance. Well, he hadn't shown up to class until late January, but they were showing no attendance. But he had been in class, so I figured that they based that on late January. So by late January, so I don't know. You'll have to check, or go to the records office and see what your status is, or the financial services office, see what your status is, or the cashier's window. Somebody there should know. Okay. And by the way, I had forgotten to turn the pages. I just started teaching from the slides here. There is a blurb here on Sir Isaac Newton, who was one of the founders of calculus. He, in addition to creating a brand new field of mathematics, calculus, he also made revolutionary contributions to the physics, including the 3 laws of motion, the law of universal gravitation, optics. I mean, he was all over the place, okay? So he's a potential paper topic. This is not a source. This is a source of ideas. You have to get your sources out of the book. I mean, somewhere outside the book. That's what I meant. Okay. And what we've been doing so far are on pages 120 and 121. Example 1's the top of 122. I hadn't been turning the pages. So we had finished this one. I think everybody finished writing. Let me clear what I wrote so you can follow up. So here's what they did. Let's pretend now they had this already. This is f of 2 plus delta x, that's f of c plus delta x, minus f of 2 over delta x. And here's where they plugged in that 2 times 2 plus delta x minus 3 minus 2 times 2 minus 3. Before minus plus 2 delta x minus 3 minus 4 minus 3 or plus 3. To me, this is a long, hard way to do it. Over delta x. Now you see your plus 4 minus 4, your plus, minus 3 plus 3, all go to 0, leaving you 2 delta x over delta x. They divide out, and that leaves you 2, the limit of 2, which is what we said, that's the slope of a line. So that should be the slope of the tangent point, okay, which is 2, okay. Limit of 2 is x approaches delta x approaches 0 is 2, okay. Now, what we have here, this is not all that clear in my mind, okay, because here's your straight line. What's the tangent of a point at a point on the straight line? It is the straight line, okay? You don't have a curve here, so you can't see what the tangent is. The tangent is that line. So the slope of the line is the slope of the tangent line. And that's why I said we know that ought to be 2, because that's the slope of the line. And indeed it was. Okay? Any questions on that? I think they're making it easy to use a line always as the first example, but you don't even see the tangent line because it's the line itself. Okay. Now, the definition of a tangent line to a curve does not cover the possibility of a vertical tangent line. Okay? Because what's the slope of a vertical line?
No, 0.
Undefined, because there's no change of y. I mean, there's infinite change of y or 0 change of x. So yeah, that's completely undefined. For vertical tangent lines, you can use the following definition. If f is continuous at c, and the limit as delta x approaches 0 of alpha of c plus delta x minus alpha of c divided by delta x, that's your difference quotient. The limit of that is delta. If that's a positive or negative infinity, then you know you have a vertical tangent line. The vertical line x equals c passing through c alpha c is the vertical tangent line to the graph. So if you come up with this being either positive infinity or negative infinity, you know you have a vertical tangent line. Draw your curve, or let your graphing calculator draw the curve, you usually will see, yep, that looks like it's got a vertical tangent line. For example, the function shown here has a vertical tangent line at c f of c. Okay? Now, they didn't give the function, so it's hard to follow how they did this. But in reality, this is, if I'm not mistaken, this may be what they call a sigmoid curve. A lot of diseases follow this curve. When you have almost no, what x represents the, well, you wouldn't have negative x's in this case. X represents the number of people affected by the disease, and y is the, if you have very low infection rate, the population, the probability of getting infected is pretty low. Then once you have greater numbers being infected, so the y is the number, x is the population, y is the number infected, then your possibility for infection gets quite high, and then at some point when just about all the population has been infected, then the infection rate dies off because everybody's had the disease. And we're probably right along here with coronavirus right now, okay? And they keep saying, oh, we've done our quarantines and things like that. Hey, you're not going to do a lot to stop that, okay? Unless they find some vaccines, antivirals, something or another, it's still going to keep climbing, okay? You may slow it down, but it's probably going to keep climbing. Okay, that's sort of off the point here. Okay, continuing the tangent line problem, trying to find the tangent line problem. And go back. There's that. I think they skipped example 2. So let's go back to example 1, and I'll write on this part. Okay. As far as I can tell, they've skipped example 2. Find the slopes of the tangent lines to the graph of f of x is equal x cubed x squared plus 1 at the points 0, 1 and negative 1, 2. Okay. As shown in the figure. We don't have the figure. Okay. Now, cynic that I am, I want to make sure this point is indeed on this graph. So how do I do that? What does this represent? X, Y. What's your Y? I see X's. Where's your Y? What is what? Huh? Okay, yeah, I see that. I see X's here, but I don't see a Y. What's your F of X is equal to Y. I tell my pre-calculus class that's the most important thing you can remember in pre-calculus algebra. F of X is equal to Y. Pretty simple, huh? That's your y. So let's see. If we plug in a 0 for x, what does that give us? 1, and that's your y. Hey, that works. How about this one? If you plug in a -1 for x, what do you get? 2. Yes, that works. So both of those points are on that curve. Now I feel better about it. Okay? And it says find the slope of the tangent line at those 2 points. So what would be your slope of the tangent line? Hint, it starts with what you see right above us. The limit as delta x approaches 0 of what? F of, okay, we're not doing 2's anymore. That's that problem. We're doing this one. 0 plus delta x minus f of 0 divided by delta x. Okay, let's see if we can do that one. What is f of delta x? That would be, I'm going to keep my limit in here. Sometimes I forget to write it. If I do, you just write it in. Okay, delta x approaching 0 of, so that would be delta x squared, right? Yay or nay? Plus 1. If you plug delta x in for x here, you'd be delta x squared plus 1, right? Yes or no? I'm sorry? Okay. 0 plus delta x is delta x. I'm just skipping steps, right? F of delta x would be, you just plug in a delta x everywhere you see an x. Okay? Agreed? Minus, what's f of 0? Say again? Really? Thought 1. You plug a 0 in for x and you get 1. We just did that earlier. And this is over delta x, right? Yay or nay? Okay? What happens up here? 1 minus 1 goes to 0. And you wind up with the limit as delta x. Now, after a while, I'm not going to write all these steps, but I'm doing it now just to get used to it. Delta x squared over delta x, because those go to 0. What happens here? One of the delta x's goes out, and then you have the limit as delta x approaches 0 of delta x. And what would that be? Say again? As delta x approaches 0, what's the limit of delta x? 0! Okay. Now, if you can picture this function, okay, so if you can get it in your head, that function, the xy plane here, is just like your squaring function. Remember your simplest parabola, but you've moved it up by 1. Okay? So at 0, 1, what is the slope of the tangent line? It's at the vertex. The slope there is 0. It's a horizontal line, slope of 0. So let's do the same thing for the next one. And by the way, the book, they put C's in here, and that's fine. So, they finally said the slope at 0 is 0. Got it. Okay. Now let's do the next one. And maybe it would be easier to put the C's in there. I don't know. Delta x approaches 0 of f of, and what would this one be? -1 plus delta x minus f of -1 divided by delta x. Okay? So what is f of -1 plus delta x? -1 plus delta x squared, right? Plus 1 minus, and what's f of negative 1? We've already done that, but do it again if you need to. 2, okay, right? There it is right there, okay. Divided by delta x, okay? And see, I left off my limit. Limit is delta x approaches 0. I tend to leave that off and throw it in at the end. So let's square that thing, and what do you get? Square this thing. Negative 1 plus delta x. Square it. Say again? I can't hear. Okay, it certainly is a 1. The shorthand here is square the first, that's 1, plus twice the product of the 2, that would be 2 times negative 1 times delta x. Negative 2 delta x, and then square the last, plus delta x squared. Plus 1 minus 2. Right? Okay? All over delta x. Now I left off my limit again. Whoa, I can't write it in, but you got what's there. Okay? Now, what happens here? 1 plus 1 is 2, minus 2 is 0. So you have a minus 2 delta x plus delta x squared divided by delta x. What can you do with that numerator? Second? Factor out what? A delta x. And that leaves you with a negative 2 plus delta x over delta x. Ha! Now the delta x's go out, and you're left with, now see, I've been leaving off my limits. I put them at the end. Limit is delta x approaches 0 of negative 2 plus delta x. That would be, delta x is going to 0, that goes to 0, and the limit is negative 2. Okay? Now, if you check in the book, that's exactly what they got. And yuck. I wish they showed the graph, because I don't like doing the graphs. But let me show it. So you got what they are. Let me erase my scratch, and I'll try to draw the graph as best I can. And here will be your, oh, this is not this one, this is the one down here. Okay, there's the x-axis, there's 1, and then your something like this. Okay, this is minus 1, minus 2. Okay, so this one, the slope of the tangent line was indeed 0. Over here, the slope of the tangent line, if I could draw it in here properly, it looks like a very negative slope, a pretty ugly tangent line, and that would be a slope of negative 2. Going down happens to be negative 2. Okay. The one in the book is a lot prettier. Now, they did it all with C's, and if you wanted to do that, you certainly could, and then you just plug in what C is. C was 0 for the first, which gave you 0, and C was negative 1 for the second one, which 2 times negative 1 is negative 2. Okay. All right, that was example 1, 2, and then what we said about tangent line problem, vertical tangent lines. I was trying to find where this verbiage is. When the domain of f, where do you see it? Oh, there it is. It's the last sentence at the bottom of page 122. When the domain of f in the closed interval a to b is the closed interval a to b, you can extend the definition of vertical tangent line to include the endpoints by considering continuity and limits from the left for x equal negative a, and from the right for x equal a, and from the left for x equals d. They're just saying you can count the endpoints if you just do one-sided limits at those ends. Okay. Now we're moving to the derivative of a function. You have now derived at, well, I'll just do what they did. I'll not read all. Okay. The limit used to define the slope of a tangent line is also used to define one of the two fundamental operations in calculus: differentiation. The other, integration. We'll get to that later. Okay? Differentiation. Here's the definition of the derivative of a function. Derivative of a function f at x, and they start with this notation, which is fine. I wish they started with the Leibniz notation. But f prime, that means derivative. Derivative of f at x is defined to be the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. Exactly what we were just doing, providing that that limit exists. So if that's a vertical tangent line, the limit's not going to exist. So then the limit wouldn't exist. For all x's in which this limit exists, f prime is a function of x. Okay? If the function is a function of x, its derivative is also a function of x. Be sure you see that the derivative of the function of x is also a function of x. They've said it 3 times now. This new function gives the slope of the tangent line to the graph of f at the point x, f of x. For any x you put in there. Okay? That's why they're using c before was probably a smarter move. Provided that the graph has a tangent line at that point x. Okay? Now, here's why I wish they had used the Leibniz notation. Leibniz notation for this is dy dx. Okay? That's assuming that the function, that y is a function of x. Okay? Now, or, actually another notation which I like even better is df dx. All these mean the same thing. And what you see here, delta was a difference, right? Well, delta is a difference when it's a finite difference. Okay? Some actual difference there. When you take the limit as delta x is approaching 0, now you have an infinitesimal difference. Not a finite difference, but infinitesimal. To me, the d's rather than delta stand for infinitesimal. Because remember this f of x, the delta y, delta f, is also getting infinitely small when this gets infinitely small. So this is dy, infinitesimally small, change of f per infinitesimally small change of x. That's exactly what you got. Change of f over change of x. And if f is y, that's dy dx. So this is a shorthand notation. I like to use this once I'm used to it. But at this point, I would have used these terminologies because it describes what's going on here a little bit better. Okay. The derivative can also be used to determine the instantaneous rate of change. Now, what do we mean by that? Okay. When you drove here this morning, I'm assuming you did. I'm also going to assume maybe you got on the interstate. And we'll assume when you're on the interstate, you may have been going fairly close to 70 miles per hour. Not too much over it, though, were you? Okay? All right. Now, that's a rate of change. 70 miles in an hour. Okay? Now, you weren't probably driving for an hour, so how do you know you went 70 miles in an hour? Well, you're doing, your speedometer told you that. What it's doing is calculating for an infinitesimally small time period. And that's exactly what you're dealing with. Instantaneous rate of change is not your average rate of change. You drove for an hour, you went 70 miles, you went 70 miles per hour on average. But this is saying instantaneous. When your time change is getting close to 0, the delta t is close to 0, that's your speed that you're going, or simply the rate of change of one variable with respect to the other. Process of finding the derivative of a function is also called differentiation. Taking a derivative is differentiation. Function is differentiable at x when the derivative exists at x, and is differentiable on an open interval a to b when it's differentiable at every point in between a and b. So those are just some of the terminologies that you have here. Okay? So in addition, like I've just told you, to f prime of x, other notations are used to denote the derivative of y with respect to x, y as a function of x. The most common of these is f prime. That's the shortest. Okay, well, not quite the shortest. dy dx, that's the delta y over delta x, the slope of the tangent line, right? Y prime, which is basically, rather than having the f up here, have y up here, so that's y prime. dy df of f of x, in other words, you just take the f of x and put it here. df dx, that's the shorthand for this. I don't know why they didn't put that in there. And then one other, and this means derivative with respect to x. So the d by d, okay, the d by d here is just capital D, x being in the denominator of the function y, or of the function f of x, or of the function f. So you can put these lots of different ways. All that means the same. Notations for derivatives. The notation dy dx is read as the derivative of y with respect to x, or simply dy dx. Okay? We don't even use say per, dy dx. Now, I tutored we have some really good friends in Birmingham named, that are from India. They had 3 boys that went through Vestavia High School and usually, and then also at college. I wound up tutoring, I think, all 3 of them at some point or another in math. The one that went to India to do his undergraduate degree, when he came back and he was in India, you just take classes, you take classes, you take classes, and at the end of all your classes, you sit through all these exams. One major final exam on every subject you've done. That's all. That's your grade. That determines whether you passed or not. Okay? That's pretty much the British system, the European system. It's not the American system. So he came home before the thing and wanted some tutoring in this. And when he said this, I had the hardest time figuring out what in the world does he say. Because, you know, Indians tend to talk a little faster. This is Asian Indian, you know. He would say, d by dx. And he would do d by dx of f of x. d by dx. I went, what? You know, I did not know. Now I know what d by dx is. And I love saying d by dx, you know, but now, at first it was mystery to me what in the world he was talking about. Okay? So there's another way you can say it. You can say d by dx, and you don't have to say dy dx. Okay. So let's do example 3. Okay? Find the derivative of f of x equal x cubed plus 2x. Use the definition of the derivative shown here, one we've been using. Okay? So your f prime of x is going to be the limit as delta x approaches 0 of, so the first thing we've got to do is figure out what f of x plus delta x is. What would that be? Roughly speaking, you don't have to give me the final answer, but just what would be your first step? Where you see an x down here, you put that in its place, right? So what would that give you? X plus delta x cubed plus 2 times x plus delta x. All right, that's it. Okay? Except now we have to cube that thing. Now, at this point, do you know the shorthand for cubing a binomial? Or raising a binomial to any power? Now, what you can do is brute force x plus delta x times x plus delta x times x plus delta x. Or if you know how to square it, then you could just do x plus delta x times x plus delta x squared. Okay? But there is a shorthand. Does anyone know it? It involves a process called Pascal's triangle. You ever heard of that? Okay, here's how Pascal's triangle does. Starts with a 1, and then it has a 1 and a 1. And then it has another 1 with a 1 here, but in between, you add these two together and gives you 2. And then you do a 1 and a 1 on the outside, add these two together, you get a 3 and a 3. And then you do a 1 on the outside, and then you add these two together, you get a 4. Add these two together, you get a 6. You add these two together, you get a 4. And then you do a 1 and a 1, 5, 10, 10, 5, 1. I'll do one more because I've got room. I'm not going to do any more than that. That would be a 6. Really? 15, good. Now the 20, 15, 6. Okay. All right, that was fun, wasn't it? Now, what does that have to do with powers of a binomial? Well, this happens to be any binomial. I'll use your x plus delta x to the 0th power. What is that? 1. Okay, yeah, we got it. And what is x plus delta x to the 1st power? X plus delta x. These are your coefficients, aren't they? And what is x plus delta x squared? We just did it a little bit ago, didn't we? Square the first, twice the product of the 2, and square the last. Running out of room. What are your coefficients? 1, 2, 1. 1, 2, 1. So, anyone want to hazard a guess of what x plus delta x cubed is? X cubed plus, now, here, let me give you a hint of what's going on here. Okay, these are the coefficients, okay, obviously, right? What's going on with the powers? Well, this is the 1st power, this is the 1st, and then you reduce this one by 1, so it's squared here, reduced by 1 into the 0th power there. This one's to the 0th power here, 1st power there, squared there. So what you're doing, the first thing is at the maximum power, and then it goes down each term by 1. The second one starts with 1 and then goes up each term. So this will be, start with the coefficient 1, x cubed. Delta x to the 0th power, which is just 1. Okay? So the next would be coefficient 3, x squared, delta x to the 1st. Right? Next, plus 3, x delta x squared. Next, delta x cubed. Okay? Because the coefficient is 1, and the x's are going down 3, 2, 1, nothing, and the delta x is nothing, 1, 2, 3. Okay. So that's the pattern. Those are your coefficients. So there's x plus delta x cubed. Now, we could have multiplied it out longhand and been done by now, but this shows you how to do it for any. This is the binomial theorem, by the way, if you need a name for it. So I'm going to erase this if it's okay. Y'all remember what this is? I'll leave that part. I'll erase the rest of it because I need the room. So you could have done x plus delta x to the 6th power and use that last row I had down there, okay? And not had to multiply anything, just write it down. Okay. So, that is your x plus delta x cubed. And then to add to this, 2 times x plus delta x, what would that be? This part. 2 That's the easy part. It's right here. 2x, 2 delta x. So there's your f of x plus delta x. X plus delta x is that thing right here. Minus, so I'm going to write it here. This is x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2x plus 2 delta x. There's your f of x plus delta x. Minus f of x, well, we know what that is. That's right here. So we're going to negate that, so that would be a minus x cubed minus 2x, right? Take that and divide it by delta x. Okay. Now I can erase this, okay? We've already used it up there. All right, let's continue the math. What do you notice you can do with that numerator? You have an x cubed here and a minus x cubed there, right? Those add to 0. Anything else? 2x there, a minus 2x there. Those add to 0. So what do you have left? The limit as delta x approaches 0 of 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2 delta x, done, divided by delta x. Now notice what you can do with that. That numerator. Say again? Let's see, do we have any like terms? Yeah, you could do that. The 3x squared delta x and the 2 delta x, is that what you're calling like terms? You could do that, but just about as easy as just, what's the F word? Factor out the delta x, okay? It's going to do the same thing you said, but maybe just a step easier. Factor out a delta x, and that leaves you what? 3x squared plus 3x delta x, because you only took one delta x out, plus delta x squared, because you took one of those out, plus 2 over delta x. Well, the delta x's go out, don't they? Okay? Now, I can take that limit, can I? As delta x approaches 0, that goes to 0, and that goes to 0 even faster. So what are we left with? 3x squared plus 2. Okay? That's f prime. At any value x, that's your f prime. Your first derivative. Okay? That's something. Now, do you mind if I cheat a little? Okay. This is just foreshadowing. Things that are going to happen in the future. In the future, we're going to learn that for polynomial functions, and this only works for polynomial functions, you can take the exponent, multiply it by the coefficient, which is 1, 3 times 1, reduce this by 1, that would be 3 times x squared plus 1 times 2 is 2, reduce that by 1, you get x to the 0th, which is 1, 3x squared plus 2, there's your derivative. Well, it's easier than taking limits, okay? But we're not there yet. So you can't do it yet, can you? Okay. But that's a good check to make sure you didn't make a mistake. All right. I can't wait for that. Okay. So there's example 3. Let's see how they did it. And by the way, example 3 was also one you can go to LarsonCalculus.com and see an interactive version of that type of example so you can hear them explain it. Maybe they'll do a better job than I did. Okay? And they probably won't tell you the shortcut yet. I did that. Okay. So let's see what we get. So it's the limit as delta x approaches 0 of f of x plus delta x is x plus delta x cubed plus 2 times x plus delta x, that's that part, minus f of x, which is x cubed plus 2x, all divided by delta x. And then they expand it, and they didn't tell you how, did they? They just said, here's the answer, okay? I showed you using Pascal's triangle, but you could do it brute force. That's legal too. That's x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2x plus 2 delta x minus x cubed minus 2x, all divided by delta x. Then they, like we did, notice that x cubed minus x cubed goes to 0, 2x minus 2x goes to 0. That leaves only terms with delta x in them, and there they are, 3x squared delta x plus 3x delta x squared plus delta x cubed plus 2 delta x, all divided by delta x. And then notice you can factor out a delta x, which they did, and left you with two terms with no delta x's, two terms that have them. Divide out the delta x's, and then, okay, write that, the numerator down again, and take the limit. Now you can take the limit because there's no delta x in the denominator anymore. By plugging it in, plug it in, the delta x's go to 0, you're left with 3x squared plus 2, which is what we got. Does that make sense? Any questions? All right. That was example 3. They're skipping examples 4 and 5. How are we doing on time? 5 minutes. Let's see if we can squeeze in example 4 before 5 minutes is up. Okay? Find f prime of x, that's what we're looking for f of x equal the square root of x. Okay? Then, we may not be able to do that. Find the slopes of the graph of f at the points 1, 1. And 4, 2. We may not be able to get them all done, but let's see. Okay? Now, cynic that I am, I want to make sure this point is truly on this function. So what does this stand for? X, y. So let's plug in for x, 1. Where's your y here? F of x, okay? What's the square root of 1? 1. That one works. What's the square root of 4? 2. That one works. Okay, so we're happy. Both of those work. That doesn't give us our slopes yet, but it tells us they are on the curve. Now, the other thing that I want to do is, let me see, I think what I would like to do is rewrite this. How can I write that in exponential form rather than radical form? Second? Don't square it. Write it as a exponential expression rather than a radical expression. X to the what power? Second? Second? No, that would be 1 over x squared. This would be x to the 1/2. Okay? Now, where did that come from? Well, what is the exponent of x? You don't see an exponent, you always assume it's 1, right? If I could get it to write. Right? Okay. Now, what's the index of a square? That's the index of 2. That's the only time in math that if you don't see something, you assume it's a 2. If you don't see a coefficient, you assume it's a 1. If you don't see an exponent, you assume it's a 1. If you don't see an index on a radical, you assume it's a 2. Okay? So how you express a radical expression is take the exponent as the numerator and the index as the denominator. Okay, so that's x to the 1/2. Okay, so here is our function, f of x equal x to the 1/2. And what's our definition of our limit? Definition of our derivative? The limit, delta x approaches 0, of f of x plus delta x minus f of x divided by delta x, right? That's what we're trying to do. So one of the first things we've got to do is, I think for this one we will leave it in radical form. I thought it might be easier. Once we do the next way, we will do that. Let's do it in radical form. It'll be okay. Sorry, I introduced that, but no harm done. We're going to use it later, okay? So this would be the limit as delta x is approaching 0 of the square root of x plus delta x, right? Isn't that? Yeah, you just plug in everywhere you see an x up here, you plug in x plus delta x there, right? Minus the square root of x over delta x. Now, remember back, at least a week ago, when we tried to do limits when we had differences of radical, what was the technique we used to simplify that? Second, rationalize in this case, the numerator. Yeah. Usually you did the denominator, but this is the numerator. How do we rationalize? Multiply by the conjugate. And what's the conjugate of that?
Square root of x plus delta x plus square root of x.
You got it. But if you do that to the numerator, you got to do it to the denominator too. X plus delta x plus square root of x. Okay? Now we've just, in a sense, simplified the numerator. We kind of messed up the denominator. But we'll live with that for now. Okay? How are we doing on time? Time's up? You can't really mean it, can you? Okay. All right. I guess what we'll have to do, now that you got a jump on it, this is example 4. We'll start with example 4 next time. But we'll start down the page right there. Okay? We'll start with that stuff right there and go from there. Let's see, did we get enough done? Oh yeah, 3.1. We can do example 5, that's at Calc Chat. You can do example 7, it's a Calc Chat. Think you can do any of the odds 9 through 13, they're all at Calc Chat. 11's a Calc View. And you can do any of the odds 15 through 25. They're all at Calc Chat. 17's at Calc View. Stop there. We'll pick up the rest of those next time. Okay? All right. Good deal. Everybody got a copy of the test? Now, the test is not due before next Thursday. You don't have to have it finished by next Thursday, but that gives you 1 week to work on it. So you can ask questions on Tuesday. You also have a weekend to work on it. If you need more time, you can have more time. You just need to get it in before I give you the next test. But try to get it done soon after next Thursday as you can. Good deal.